6.1 is on graphing quadratic functions. So it's all about parabolas, if you remember parabolas from Algebra 1. Okay, so a quadratic function is going to be a function that looks like f of x equals ax squared plus bx plus c. So in your distant memory, quadratic formula, oh yeah, ax squared plus bx plus c. We're going to have that this chapter. Yes, there's a song. All right, the quadratic parent function is f of x equals x squared. So a parent function is basically like the most basic function that has the characteristics of a parabola. So it looks like a parabola. So our parent function is y equals x squared. So if we do a t-table for that, this should be a t-table that you guys should definitely like know how to do quickly. Like you'd have 0, 0, 1, 1, 2, 4, negative 1, 1, right? Negative 1 squared is also 1. Negative 2, 4, and so on. So we're going to have 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay, so it looks like this. So you're going to graph that parabola a million times. You're going to know exactly what points are on that. Okay, so it says graph f of x. Oh, so it says notice the graph of f of x equals x squared is a U-shaped curve that's called a parabola, not a parabola. Don't call it parabola. It drives me crazy. Parabola. All right. Graph f of x equals x squared plus 4 by using a table. So same idea. We're going to graph x squared plus 4 now, though. So y equals x squared plus 4. So if I plug in those same points, like 0, 1, 2, negative 1, and I'll do negative 2 as well. I have 0 squared is 0, plus 4 is 4, 1 squared is 1, plus 4 is 5, 4 plus 4 is 8, 1 plus 4 is 5, 4 plus 4 is 8. So we have 0, 4, we have 1, 5, we have 2, 8, we have negative 1, 5, and we have negative 2, 8. So it looks just like that parent function, except it's been moved. So where did it move? So it moved up 4. And it kind of makes sense because on the end of our function, we just tacked on a plus 4, right? So it's like we had the x squared from before, right? All the same y values, and then we tacked on plus 4. Yeah, Alex?
Does it matter how many points you use?
Does it matter how many points? No, I would have at least 3 for a parabola. You know how like a line you need 2? Parabolas, you should have at least 3. And you should definitely like see the curve of the parabola. If you're just doing 3 and it's like, oh, they're like here, that's not telling you anything. Like you probably need another one over here somewhere. Does that make sense? All right. So the next one, so it says graph f of x equals x minus 3 squared by using a table. So same idea. Any thoughts on where this one's going to move? What would you think? 3 to the right. Ooh. Why not left?
You already did it.
All right, let's see. You're already ahead of the game. You knew where it was going. So if I have x and y equals x minus 3 squared, I always like to tell people to think about what makes the y value as small as possible. Can you guys kind of see that in your head? Like you're going to square a number. What can I plug in for x to make it 0, basically? Like that's the smallest that you can get after you square something. So what do you plug in? 3. Okay, I put that in the middle of my table. That's going to be where my vertex is. So when I plug in 3, I get 3 minus 3 is 0, 0 squared is 0. Okay, that's the smallest it can possibly be because I'm squaring something, right? I'm not going to get a negative number out. And then I plug in things on the right and the left of that number. So if I plug in 4, I get 1 squared is 1. If I plug in 5, I get 2 squared is 4. If I plug in 2, I get negative 1 squared is 1. And if I plug in 1, I get negative 2 squared, which is also 4. So see how it's kind of symmetric when you put it in the middle? Kind of nice, yeah.
Does it matter what number you use as x? Would 3 have to be in the middle?
It doesn't have to be in the middle. But what a lot of people do if they're just doing a t-table is they tend to pick these points, which is okay, but like doing negative 2, right, you're going to get negative 5 squared, which is 25. Like that's not helping me on my graph. Do you guys see that? So it's like way big, and this one would be 16. Like it's not really helping you. So you kind of want to see where it's like curving, where it's going back. So really, like if you had done these points, you wouldn't see like the vertex. You wouldn't see where it loops back around and makes the U. All right, so I have 1, 4. I have 2, 1. 2, 1, not 2, 2. 3, 0, 4, 1, and 5, 4. So there's my U shape. Okay, so you guys said that it moves to the right 3, which to me I think is kind of the opposite of what I would think, because I would look at this graph and I'd say, oh, -3. -3 means move to the left, right? Negatives are on the left side. Okay, and it actually doesn't do that. So it's a little bit confusing. So we're going to talk a lot about this later in the chapter, but let's kind of preview it now. So in the last example, what you were doing is you were just tacking on a +4 at the end, right? You had your x squared, like we always had, and then we tacked on +4. So all of the y values we had before, we just added 4 to them. Okay? But this one's a little bit different because it's actually inside. Like you have x minus 3. Like the 3 is inside with the x. It's before you even square it. Do you guys see? So it's affecting the x value. So whenever something's inside parentheses, it changes the x value. And what happens is it does the opposite of what you would think. So when you see -3, it actually goes to the right 3. It's kind of weird. And the reason is because of this right here. Because our original t-table for x squared, like y equals x squared, if I wanted to get 0 out, I had to plug in 0. If I wanted to get 1 out, I plugged in 1. If I wanted to get 4 out, I plugged in 2. So how are these numbers different than these numbers? You added 3, right? So that's that kind of thinking that's making you do the opposite. It's saying, oh, wait, to get 0 out, I add 3. I put in 3 instead of 0. Do you guys see? That's where the adding 3 comes into play. It's saying I want to get the opposite. Like I want to undo this operation of this. All right, so anyways, the axis of symmetry is the line through the vertex of the parabola. I always tell people it reminds me when I was like a little kid. My mom always had me do like those little paint butterflies. So she'd give me like a butterfly, and on one side I would like paint the one side, and then I would fold it while the paint was still wet, and then I would undo it, and then I'd have the same thing. And I'd be like, oh, it's exactly the same, Mom. Like, it's like the coolest craft for a little kid, right? Not really, but I thought it was really cool. That's what an axis of symmetry is. Like, whatever points you have on the right side, they're going to match up with the ones on the left side when you do the fold line. Okay, so that's the axis of symmetry. So, like, the axis of symmetry here is 3. That's what I was putting in the middle, the fold line. All right, so properties of parabola. It says if you have ax squared plus bx plus c, the parabola has these properties. It opens upwards if a is greater than 0, so it opens up, and downwards if a is less than 0. So if I have like y equals positive x squared, it's upwards. If I have y equals a negative x squared, it's downwards. All right, the axis of symmetry is found by doing negative b over 2a. So x equals negative b over 2a. That's something you need to memorize. The vertex is at the point. You have the x value. Like if you draw on your axis of symmetry and you're like, oh, it's at x equals 3. So if you want to find the y value that goes with it, you just plug in 3 into the original. So the way this is written is negative b over 2a, comma, f of negative b over 2a. So it's basically saying whatever value you get for your axis of symmetry, plug it in to find the y value that goes with it. And then the y-intercept, just like we did with equations of lines, right? To find a y-intercept, we plugged in 0 for x. Same thing here. So we plug in 0 for the x value. So like this part and this part would go away. You'd end up getting c. So 0, comma, c. Okay, so we're going to do a lot of examples, and your homework has like 6 examples that are like this. Okay, so it says for each of the following problems, complete these steps. So first, we determine whether it opens upwards or downwards. We find the axis of symmetry, the vertex, the y-intercept, and then we sketch a graph. Okay, so starting with part A. So I want to see what A, B, and C are. So A is 1, B is 2, C is -1, right? I'm identifying like the coefficients, just like synthetic division in the last chapter, like 1, 2, -1. All right, so I have A. A is positive. I'm only worried about if it's positive or negative. So if it's positive, it opens upwards. All right, smiley face. All right, B. Find the axis of symmetry. So I have x equals negative b over 2a. So I have negative 2 over 2 times 1. So negative 2 divided by 2 is negative 1. Okay, so on my graph, I'm going to go to x equals negative 1, and I'm going to draw in that vertical line. That's my axis of symmetry. That's my fold line. All right, C. I'm going to find the vertex. So I know that my vertex has to be located along that axis of symmetry. I just don't know where it is, how high or low it is. So I plug in negative 1 into my function. So I have negative 1 squared plus 2 times negative 1 minus 1. So I get 1 minus 2 minus 1. So I get negative 2. Okay, that just found a point. I plugged in negative 1 and I got negative 2 for the y value. That's my vertex. So negative 1 comma negative 2. So right there. Okay, I know my parabola is opening upwards, but I really don't know like how skinny or fat the parabola is. So my parabola could look like this, or it could look like that. Like, I don't know. Okay, so I need at least one other point. Okay, so I find that point. The easiest point to find is plugging in 0 for the x value. So I find the y-intercept, 0 for x. So when I plug in 0 for the x, I get 0 squared plus 2 times 0 minus 1. It's always that last number. It's the c value. So I get 0 for x, negative 1 for y. So I have 0, negative 1. And once you have that point, you actually have a third point. And that's what Alex was saying, like, how many points do you need to graph the parabola? And I said, at least 3. You need something on both sides of that vertex. So do you guys see with the fold line where the other point would have to be? It'd have to be at negative 2 comma negative 1. Do you guys see it? So basically, like, you count over, like, from that point, you go 1 over to the axis of symmetry and then 1 past it. All right, and that's enough. So then you have your parabola. All right, so same steps for the next one. So part A. So I decide if it opens upwards or downwards. So in this case, A is negative 2, B is 8, C is 5. Okay, so for part A, I have A is negative. That means it's going downwards. All right, B. I want to find the axis of symmetry, so I do x equals negative b over 2a. So I have negative 8 divided by 2 times negative 2. So negative 8 divided by negative 4. So I get negative 8 divided by negative 4 is 2. Okay, that's telling me my axis of symmetry. So dotted line at x equals 2. But it's not telling me like where my vertex is located on that. So I need to plug in 2 into the function. So f of 2. So I have negative 2, and then I have parentheses 2 squared, plus 8 times 2, plus 5. So whenever I plug a number in, I keep it in parentheses so I can keep track of the negatives and so on. So the order of operations, I do my 2 squared first. So I get 4 times negative 2, so negative 8, plus 16, plus 5. So I get 8 plus 5, so 13. So that's a point. It's 2 comma 13. I plugged in 2, I got 13. It's like 1 away from the very top of your graph. It's like right here. All right, but that doesn't tell us like how skinny or fat the parabola is. We need at least one other point. So the easiest point to find is the x-intercept. Now be careful, like on your homework, I think I have one where the vertex is actually on the x-intercept, or the y-intercept. I'm saying x. It's on the y-intercept. Like they're the same thing, I guess. So if that happens, you actually need to plug in some other point. Like do a t-table and plug in like 1 or 2 or whatever. So sometimes that will happen where you can't, like it's already on the y-axis, so you can't find another one. All right, so let's say I plug in 0. If I plug in 0, I get negative 2 times 0 squared plus 8 times 0 plus 5. It's always that last number, so I get 5. So I have 0 comma 5. What other point do I have to have on my graph? Over here, what point is that? 4, comma 5. Do you guys see it? So that's it. So like I was saying, if I had a point that was the same as the y-intercept, if my vertex was the y-intercept, you'd have to do another point. So you'd have to plug in like 1 and get something else. Okay, so in this case, if I plugged in 1, I have -2 plus 8 plus 5. I'd have 13 minus 2, so I'd get 11. So it'd be like right there. So if that happens, you can always find another point. Okay, next step. So same stuff. This one's a little bit different. So I have f of x equals 8x minus 4x squared. It's not in that form, so I need to rewrite it. I need to see it as -4x squared plus 8x plus 0. So I can see a is -4, b is 8, and c is 0. So I need to write it in like the descending order, the standard form for polynomials. All right, so a is negative. So it's going to open downwards. B, I do my x equals negative b over 2a. So I get -8 over 2 times -4. So -8 divided by -8 is 1. C, I want to find the y value that goes with that 1. So I find f of 1. So you can plug in here or the standard form. It doesn't matter. So I have 8 times 1 minus 4 times 1 squared. So I get 8 minus 4, which is 4. So that means my vertex is 1, comma 4. So right now I have the axis of symmetry at 1. I have 1, comma 4 as my vertex. I know it's going to go downwards, but I need at least 3 points. So I'm going to plug in 0 to find the y-intercept. My y-intercept is going to be 0 minus 0. So 0. All right, so if I have that point, then I move right 1 to get to the axis, and I go right 1 again to get my other point. So it's a really skinny parabola. So it looks like that. Okay, if you needed another point, you could always plug in something else. All right, you guys try 4. 4 actually, I think, runs off the grid. So you can do another point if you can't do the y-intercept. All right, so on this one, so you have a is -1, b is 6, c is -8. So the first thing is a is negative, so it opens downwards. And then part B, you do your x equals -b over 2a, so -6 over 2 times -1. So you should get -6 over -2 is 3. So that's your axis of symmetry. So x equals 3. But you want to know where your vertex is located, so you plug in 3 into the original, f of 3. So I have negative, and then I'm going to have 3 squared plus 6 times 3 minus 8. So I have -9 plus 18 minus 8. So if you had any errors, this is probably where it was. So -17 plus 18 is 1. So your vertex is 3, comma 1. It's right there. That's why I was saying the grid's a little bit off. I should have put my x-axis higher. Yep.
So how did you find the 3?
I did -b over 2a. I did this formula. So my b was -3.
Oh, and then this c.
All right, and then for part D, I want to find my y-intercept. But in this case, if I plug in 0 for x, I get -8. So 0, -8. And it runs off the graph. So you can kind of like do like little tick marks to go all the way down to 8 if you want. Or you could just choose another point. So this is what I was talking about. Sometimes you might need to do one additional point. So let's say I plug in 2, because that's really close to my vertex. If you plug in 2, you get negative, right, 2 squared plus 6 times 2 minus 8. So you'd have -4 plus 12 minus 8. You actually get 0. So 2, comma 0. And that means you would also have 4, comma 0. So then you can draw on your parabola. All right, so when we talk about the domain and range, we talked about this before. The domain is all the x values on your graph, and the range is all the y values on your graph. So in chapter 1 or 2, I don't remember, I would always talk about taking your pencil and moving like from the left to the right to find the domain, and talking about all the x values on your graph. So if we go back to number 1, your domain is negative infinity to infinity. You have every x value graphed. Do you guys see that? It goes out forever to the right and left. It just keeps getting bigger and bigger and bigger. So previously I talked about running your pencil along and finding all the places where it's intersecting. It's going to intersect everywhere. Okay, that will always be true for parabolas, unless they're on their side, which we'll talk about in another chapter. These are all going to be functions, though. So functions are not going to be like a parabola on its side would not be a function. Do you guys see that? So all of these quadratic functions are going to have the same domain. They're going to be negative infinity to infinity. Okay, but your range, that's a set of all the y values you have. So if you run your pencil from the bottom up, so like this, what's the first y value you hit? -2, right? So your range is going to be -2 to infinity. And we do a bracket because we include that point, -2. So for number 2, our domain is negative infinity to infinity, but the range is negative infinity, right, starting from the bottom and going up. And what's your highest point? 13. Do you guys see it? Negative infinity to 13, bracket. Okay, so if you have a minimum, you're going to start from the lowest point and go to infinity. If you have a maximum, you're going to start from negative infinity and go to the maximum point. All right, so the next two, so your domain for number 3 would be negative infinity to infinity. And then the range is going to be negative infinity, and then you go up to a height of 4. So 4 bracket. And then number 4, your domain, again, negative infinity to infinity. And the range is going to be negative infinity, and then it goes up to a height of 1 bracket. Okay? All right, so that brings us to maximums and minimums. So there is a way to notice right away if you're going to have a maximum or a minimum for a parabola. Okay, think about it. If A is positive, so if that first value is positive, we have a parabola that opens upwards. So you guys see my hand opens upwards like this. If it's opening upwards, will it have a max or a min? It will have a min. So if A is positive, you're going to have a minimum. If A is negative, then that's when it's downwards like this. Right? That would be a maximum. Okay, so you're going to have a lot of you could have lots of story problems that say, find the maximum profit for this equation. Find the maximum cost. You could have that. It's just doing the negative b over 2a thing still. Okay, so number 1, it says find the minimum or maximum value of f of x equals x squared plus 4x plus 4. So in this example, A is positive. So that means it opens upwards. So if it opens upwards, then there could be there will be a minimum. Okay. So we want to find that minimum value. So just a minimum. Okay, so we're going to do our x equals negative b over 2a. So I have negative 4 over 2 times 1, right? Because you have a is 1. You can write them if you need to still. A is 1, b is 4, c is 4. So you have x equals negative 4 over 2, so you get x equals negative 2. That is your axis of symmetry. But it's not telling you how high or low the points go, right? It's just telling you that your vertex is located on that line somewhere. Okay, so that's when we always plugged in. So we plug in our negative 2 into our function. So negative 2 squared is 4. Minus 8 plus 4, we actually get 0. So we have negative 2 comma 0 is our vertex. And we know it opens upwards, right? So you could find the y-intercept if you want to. It's actually at 4. You don't need to, though, because I just had a little rough sketch to show that it's a minimum. So our minimum is located at that point right there. So a lot of teachers will just say, oh, just say minimum is at this point and just say negative 2 comma 0. Okay, but I have you write it a special way because you're going to have to do this later on in your math classes. When you talk about a minimum value, you're talking about how high or low it goes. In this case, low, right? Minimum value. So what's the lowest y value you have? 0. That's your minimum value. So we write it as minimum of 0, right? So that's the y value, at x equals negative 2. So we don't write it like a point. We just say we have a minimum of 0, basically. Okay. All right, so you might have some like story problems on these types of things. This one's a little bit tricky. So it says Olivia's shop sells about 200 infinity scarves each month for $6 each. She estimates that for each 50-cent increase, she will sell about 10 fewer scarves per month. How much should she charge in order to maximize her monthly income? The other class was confused. They were like, wait, she sells an infinite number of scarves? No, these are like special types of scarves. So they like have no end, like one infinity scarves. Oh yeah, they just keep pulling them out, the magician, yeah. That's funny. All right, so in order to find the monthly income, you're going to find how many scarves she's selling and the price that she's selling them for. All right, so the number of scarves. I said she started out selling 200, and they were $6 each. So her monthly income would be $1,200 in that example, right? Okay, but she's trying to maximize her income. So maybe she can like sell them for a higher price, right, but not make as many scarves. So less work, but more money. That's that's the ideal situation, right? Less work, more money. Okay, so she's saying she noticed that as she raised the price, if she raised it to $6.50, she sold like 190 scarves. She lost 10 scarves. Okay. And if she sold it for $7, then she only sold 180. Okay. So we need to find a general equation. Okay, so what we're going to do is we're going to say let X equal the number of 50-cent price increases. Okay, so we don't know what price she's going to sell it for. We're going to have this in terms of X. So the price, she started out at $6, but if she has X price increases, it's going to be plus 50 cents times X. All right, does that make sense? So that's the number of price increases. So if she increased it like 5 times, it'd be 6 plus 250, so it'd be 850. Okay, so then if she increases it X number of times, what is the number of scarves that, how many scarves is she selling, I guess? Minus 10 what? X. So you have 200 originally, but you're subtracting out 10 for every price increase. So minus 10X. So like I said, if she sold her scarves for $8.50, right, 5 price increases, she would have lost 50 scarves. So she'd have 150. Do you guys understand where this is coming from? So her monthly income ends up being like number of scarves times the price. So we'll call that Y. And at first glance, it doesn't look like it's actually a parabola, but it is. Okay, it's just not in our standard form. It's not in the ax squared plus bx plus c form. Okay, so we multiply it out. So we're going to FOIL. So I do the 200 times 6, so I get 1,200. Then I do 200 plus 50, or 0.5x, so I get plus 100x. Then I do negative 10x times 6, so I get negative 60x. And I do negative 10x times 0.5x, so I get minus 5x squared. So your function is really y equals, let me write it in the standard form, negative 5x squared. These will combine, so plus 40x plus 1,200. Okay, now you can tell it's a parabola. And not only that, I can tell that it's a downwards parabola. So a downwards parabola will have a maximum, right? So I can find the maximum income for Olivia. Okay, so this is a very simplified problem. Like, they're obviously a lot harder in the real world. I'm sure Olivia could, you know, just like do $6, $6.50, $7, $7.50, $8 and find out what her maximum income is going to be. She would probably not do a quadratic function, but it's a simplified version of something that we do in real life all the time. All right, so I'm trying to find that maximum. So I'm going to do x equals negative b over 2a. So I get negative 40 over 2 times negative 5. So negative 40 over negative 10 gives me 4. What does that represent in this problem? What does 4 mean? What does that mean? It's the number of price increases, right? This is number of price increases. So what price should she sell it for? She should sell each one for $8. Okay, so if I want to find her monthly income, I could just say, oh, it's going to be 200 minus 40, right? Because she's losing 40 scarves by selling it for that more expensive price, right? And then I could take that price and I could multiply by, or I could take that amount and multiply by the price. Okay, or you can plug into this formula that we just found. So I have -5 times 4 price increases squared plus 40 times 4 plus 1200. So 4 squared is 16. So -80 plus 160 plus 1200. I think you get 1280. Did you guys get that? All right, that's her max income. So max income of 1280. And then at $8 per scarf. So I also asked how much should she charge? So that's your answer. So a little bit tricky. Yeah. Well, it's interesting because in real life problems like this, like sometimes that's not the solution. So he's saying like, what if you had an infinite number of materials, an infinite amount of space, and so on? Well, maybe you're buying a machine or you're buying workers, like you're paying workers to make these scarves for you, but it's not really like worth it in the end because your cost is so much that maybe you would lose money. Or she's not selling enough. The demand isn't enough for infinity scarves to do that. So it's kind of an interesting situation.